everybody, today we're going to talk about multiplying complex numbers and finding complex conjugates. When we multiply complex numbers, it's important to write numbers in standard form before multiplying and to rewrite powers of I. This means anytime you get to I squared, you want to rewrite it as -1. Let's start by simplifying 6i times 4i. We know that 6 times 4 is 24, and I times I gives us I squared. We're going to replace the I squared with a -1, and then multiply 24 times -1 to get -24. Notice that I multiplied a complex number times a complex number, and I got a real number in this situation. Let's try simplifying the square root of -25 times the square root of -4. The first thing we should do is rewrite both of the numbers. Instead of writing the square root of -25, I'm going to write 5i, and the square root of -4 will be replaced by 2i. Now I can multiply 5 times 2 to get 10, and I times I is I squared. Once again, we'll replace I squared with a -1, then multiply 10 times -1 to get -10. Once again, we multiply two complex numbers and we got a real number. That's not going to happen every time. Our next example says 5i times 6 plus 3i. As I'm multiplying these two complex numbers, I want you to think of distributing the 5i to the 6 and the 3i. I have 5i times 6 is 30i, and then 5i times 3i gives me 15i squared. I'm going to replace the I squared with a -1, so I have 30i plus 15 times -1, and then I'm just going to rewrite my final solution. So instead of writing 30i minus 15, I'm going to flip that around and make it -15 plus 30i. That way, I'm once again in standard form. Our next example says multiply 8 plus 6i times 2 minus 7i. So even though we're only multiplying numbers, this probably makes you think of multiplying binomials. So we're going to do the same kind of distribution of numbers. I'm going to start by doing 8 times 2, which gives me 16. Then I'll multiply 8 times -7i, which is -56i. I'll move on to 6i times 2, which is 12i. Then I finish by multiplying 6i times -7i, which gives me -42i squared. To simplify, I can combine -56i and 12i to get -44i. I'm also going to change the I squared into a -1. Now I have 16 minus 44i minus 42 times -1. -42 times -1 is a positive 42. Now I can add 16 to 42, which gives me 58 minus 44i as my final number. This time I multiplied two complex numbers together and I got a complex number as my solution. A special type of complex number is called a complex conjugate. It starts with the number a plus bi and coming up with the second number a minus bi. Notice they have equal real parts, a and a, but their imaginary parts have opposite signs, b and -b. For example, 5 plus 4i and 5 minus 4i are complex conjugates. Let's try finding the product of complex conjugates 2 plus 3i and 2 minus 3i. To start, I'll multiply 2 times 2, which gives me 4. Then 2 times -3i will give me a -6i. 3i times 2 gives me a positive 6i. And then 3i times -3i is -9i squared. Notice the -6i and positive 6i cancel each other out. I can also change the I squared to a -1. So now I have 4 minus 9 times -1. This becomes 4 plus 9, which is 13. This leads us to a very helpful equation. A plus bi times a minus bi equals a squared plus b squared. Let's try that one more time. We're going to first find the conjugate, then multiply the numbers together. So I'm given 4 plus 3 times the square root of 2i. The conjugate will be 4 minus 3 square root of 2i. Now we can multiply the two together. Because we have complex conjugates, I know that I can use the formula a plus bi times a minus bi, which is a squared plus b squared. So I'm going to square the 4 and add it to 3 times the square root of 2 squared. Remember, your final solution does not include an I. 4 squared becomes 16, 3 squared is 9, and then I square the square root of 2, which just becomes 2. This simplifies to 16 plus 18, which is 34.